Welcome back to Math 7 with Mr. Passon. Today we're continuing Unit 2. That is studying proportions. We are on Lesson 5, which will talk about proportional relationships. Go ahead and go into Canvas, pull up the notes. Here's a link to the slides right here, so go ahead and make a copy of those. And we're going to talk about these, what we're talking about when we're talking about proportional relationships. Here we're going to focus on the model. Alright, so I'll give you a minute to get that up. Well, you can just pause the video if you need to get it up and ready to roll. I'm going to view this at 100%, so it's a little bit bigger. And actually, maybe we can go all the way up to 200% on this one. Yeah, that still fits. So, first thing, go ahead and put in your name. Put in the date and which period class you're in, because we do have our first notebook check coming up. And if I ask for these notes, well then you'll know, I'll know which period you're in. Alright, so what is a proportional relationship? Well, proportional relationships represent a constant rate of change. Now that seems kind of weird. Constant means something that stays the same, and change means something that doesn't change, that is changing. So what we mean when we say a constant rate of change, it means that when we calculate a rate, that it's always going to stay the same value. The x values and the y values, or the inputs and the outputs, are going to change, but the rate at which they change, or the slope of their line, is going to stay the same. Okay? Now, two things will be true about a graph that is proportional. The graph will be a straight line, and the graph will go through the origin. Okay? Now, we're going to check this out, and we're going to look at some of the reasons, but let's think about what's going on in the background here. Let me grab my drawing tool. So if we write our model, which is y equals k times x, right? So an example of this would be y equals 5x. Oh, not 5 minus x, 5 times x. So if I put in 0, well then I'm going to get out 0. So we see that it has to go through the origin every time. And if x doubles, well then y is also going to double. If x is 5 and then goes to 10, then y starts out at 25 and ends up at 50. So every time when we go over to the right a certain amount, if we double something, then we're going to double the height as well. Okay? So every time we go over a certain amount, we have to go up a certain amount in proportion. Alright? Now, in a table we can check to see, if we want to check for equivalent ratios, we just do y divided by x. Right? So y divided by x will always be, oh, and I need to get back to click actually in the boxes, will be constant. So y and x are always changing, but if we do y divided by x, we're always going to get the same value. Let's go ahead and look here. We need to do our division. Let me go ahead and clear out the work that I've already done. To find our ratio, right, and let's think about which is going to be our x and our y. So here I'm probably going to go ahead and have, and actually I'm going to go ahead and throw in a text box here for this, so it stays in our notes. Alright. So we're going to think about which of these are our x and our y. So this is going to be our x, and this is going to be our y. Now, let's go ahead and figure out y divided by x. So let me grab here, and we're going to do our division. So we've got 84. Divided by 3. It's going to go in 2 times there. 2 times 3 is 6. Then we get 20. Bring down the 4. We get 28. Alright? So we're going to think about that as we're going along. 1 hour should be 28 miles. Okay, go ahead and pause the video here. Put in the remaining values as you figure them out, and then I will put them in after you've come back. So now you should have calculated each one of the values, and this one should be 56. This one should be 112. This one should be 140. This one should be 168. This one should be 196. Then we get 224. And then we get 252. And here, each time, it was this number times our ratio. Okay? Now we want to plot these, so we're going to need to go ahead and place in x and y values. So along our x, we're going to do 0, 1, 2, 3, 4, 5, 6, 7. Let me get that one lined up a little bit better, and maybe that 5 lined up a little bit better. Eight and 9. Now we're going up to 250, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we really want to go up by about 25 each time. So we're going to have 25, 50. Oh, I don't want that one. I want this text box over here. So 25, 50, 75, 100, 125, 150, 75, 200, 225, 250. Alright. So I'm going to start with 250 up here near the top. Then do 200, and then just subtract off 50 each time. And then we're going to space those out, so that way they sort of match every other line. We'll just make the text slightly bigger. And that should make everything fit. Cool. Alright, now let's grab our line tool. And we're going to plot our different points. So first thing I'm going to do is I'm just going to plot them here. So I've got 1 and 28, which is just a little bit above there. Right? 256. 384. So here's 75, 80, 84. Somewhere in there. 4 is 112. 5 is 140. 6 is 168. 150, 75, so 68 is closer to here. Then we've got 7 and 196, which is almost 200. And then 224, which is very close to our 225 here. And then 252, which is right above our top line here. Alright, so then if we grab our drawing tool over here, we know it's going through the origin, and it should pretty much go through each one of our lines, so it should look something like that. Now I'm going to erase my extra work, and we've got our line there. Our equation is y equals, what was our value again? 28 times x. Our verbal description is every hour we travel 28 miles. And proportionality, well, the constant rate of 28 miles per hour. It's a straight line and it passes through the origin, so definitely it is proportional. So it's constant rate, and that was given to us by the fact that it was a straight line, and then it was through the origin. Good. Let's go ahead and look at page 2. So again, you're going to try to figure out the model here. Oh, I keep going past it. So let's read the scenario, and then we're going to go ahead and figure it out. The Student Council is selling t-shirts to raise awareness for the local animal shelter. For each t-shirt they sell, they will donate $7. Okay. So now we're going to look at the number of t-shirts. So if you, I suppose we could fill in these as well, actually. So let's grab our little text box tool. So here's our number of t-shirts. I'll just make that text smaller so it fits. I guess I need to highlight it before it. And we can put another one here, donations. Alright, so for 5, let's go ahead and fill out the table. Remember, for each shirt, they're going to be $7, so how much would you donate for 7 shirts? Go ahead and fill out the table. Alright, you should have already filled out the table. So I'm going to give you the numbers that I got. And our formula was y equals 7x, or y equals 7 times x. Alright, now again, we're going to regularly drop out that multiplication, but anytime we have a number next to a letter, that means that we're going to have a multiplication. So, again, I want you to set up your scale, figure out what's appropriate. So it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going up to 45, so it looks like you would want to go by 5s over here. And then we have to get all the way up to 315. So I would say maybe go up by 30s on this side, and you would get there. Alright? And yes, this model will again be proportional. Alright. Now let's look at these. We're going to go ahead and answer these questions. Read each scenario, determine if the situation is proportional or not. If it's proportional, then write an equation to represent it. A restaurant charges $10 for a medium pizza and $1 for each topping. Pause the video, write in what you think it is, and then I'll answer. Okay, you should have come back. This one is not proportional. Alright, the main cost is the pizza, but the cost changes, so the ratio changes each time. Let's read this next one. A restaurant has an all-you-can-eat buffet. They charge let me say that again. A restaurant has an all-you-can-eat buffet. They charge $8.75 per person. Go ahead and fill in where you think it's proportional. And yes, it's proportional. And our model is cost equals $8.75 times n, the number of people. Okay? Now, I chose not to use x and y because I wanted it to make more sense. We're often going to use n for a number of people. We're often going to use c for cost. Let's read this next situation. A restaurant charges $1.50 for a fountain drink with free refills. Alright, this is not proportional. Okay? So if you drank one drink, you'd pay $1.50. But if you drank two, you'd still pay $1.50. If you drank three, you'd still pay $1.50 because your refills are free. Alright? Let's read 6 and, ooh, it looks like 6 got repeated, so it's actually 6 and 7. Alright. So, a restaurant has a build your own salad option. It's $3.80 per pound of salad. Think about it, put in your answer. Proportional. Our cost equals $3.80 times the weight of the salad. I'm just going to use X. I would think of something per pound, but I didn't want to use P for pounds. Alright, so here our cost is based on the number of pounds we had. A vehicle travels at a rate of 65 miles per hour. Proportional. Now here they told us the rate. They told us the rate was constant. So our distance equals 65 times our hours. Or D equals 65 times T for time. Okay? So now we can take our situation and identify whether it's proportional or not proportional, and we can make applications of it. Go ahead and summarize what you learned today. Let's drop another text box in there. You should be good to go. And then I will see you next time. Please don't forget about the assignment associated with this one. And have a good day. See you next time.